This video is about an algebraic skill called completing square. If we start with a quadratic expression like y is ax squared and bx and c, this completing square skills help us to change it to a times a complete square plus another constant. Alright, that is the process from the black to the red. It's called complete square. Now the purpose of the complete square is to help us find the maximum or the minimum value of y. Whether it is a maximum or minimum depends on a. If a is a positive number, then there is a minimum value. On the other hand, if a is a negative number, then there is a maximum value. We'll talk about that later on. And thirdly, finally, when you have the completing square finished, we can find the position of the vertex of the parabola. The vertex means the point where the parabola turns around. Say this point is the vertex. If it is opening up, this is the vertex. Alright. So let me show you some of the process in two different examples on how to do the completing square. Alright, so let's start with an easy one. Example 1. We want to find the maximum and minimum and the position of vertex of this parabola. Y is x squared and 6x minus 1. Alright. So in order to do that, we have to find a magic number to fulfill the complete square. And that magic number is to take the x coefficient. In this case, this is a 6. 6 divided by 2, and that is a 3. We take the square of 3, and that is 9. 6 divided by 2 is 3. The square of 3 is 9. So the magic number is 9. Alright, so we have x squared plus x, 6x, and we add 9 to it. Alright, but we cannot just add 9 out of nothing. We have to balance the equation. So at the same time, we have to subtract the 9. Add 9 and subtract the 9, so nothing is changed. But then the first part, the part here, will be changed into a complete square, like x and 3 complete squared. And then we collect the rest of the constant, we call them the residuals, into here. So that is minus 9 minus 1, and that becomes 10, alright? That becomes minus 10, it becomes minus 10. So that is the complete square. We started with this expression, y is x squared and 6x minus 1. Now we have this expression, y is x and 3 squared minus 10. Alright, so what do we extend from here after we have this? Now, first of all, we know that x plus 3 squared, being a complete square, is always non-negative. It's always greater than or equal to 0. So the minimum value of x plus 3 squared is 0. Right? The minimum value of that 0. So that extends to the minimum value of y will be minus 10. Alright, the minimum value of y when x plus 3 complete square is 0. So the minimum is minus 10. And that happens when x is minus 3. And the minimum value occurs when x is minus 3, when the complete square is 0. Alright. And now if you think about the shape of the parabola, the shape of the parabola, it shows a minimum, so it should open up. It should open up, and that particular minimum value will be this point, alright, and that is the position when x is minus 3 and y is minus 10. So this is the position of the vertex. This is the position of the vertex. We get it from the result of completing square. We get it from the result of completing square. Alright. So we have the complete square method, we have the maximum minimum. How to find the maximum minimum? We have the position of vertex. So now, but that method I just showed you, it only works when the leading coefficient is a 1. Alright. If the leading coefficient is not a 1, I will show you another case how to deal with it when the leading coefficient is not a 1. Say y is minus 2x squared and x minus 2. Alright. We want to do the complete square, find the maximum minimum and the position of the vertex. Alright. So once again, now if the leading coefficient is not a 1, we have to make it 1. We take the minus 2 out here. Alright. And we also have to take the common factor minus 2 from the x term. So it should be minus 1 over 2, alright. We can leave the constant. We can leave the constant here, alright. it does not participate in the complete square until the very end. Right? We have to get the minus 2 from the x squared term and also from the x term. Alright, now we can do the complete square inside the square bracket. Alright, so think about the magic number. The magic number will be this 1 over 2 divided by 2 becomes 1 over 4. Taking the square is 1 over 16. So the magic number is 1 over 16. Alright, but once again, we cannot just add 1 over 16 out of nothing. We have to minus 1 over 16 in order to balance the equation. Alright, so the rest remains the same. Now, the first part changes to a complete square. This part changes to a complete square. This portion, alright? So that becomes x minus 1/4 squared. Alright, the minus 2, I copy the minus 2. And the rest of it, the minus 1 over 16, combined with the minus 2, becomes plus 2 over 16. Alright, and then we still have the minus 2. Alright. So after all, the result should be minus 2 x minus 1 over 4 squared, and that is minus 15 over 8. So how do we read this result? Right? Note that for the minus 2 x minus 1/4 squared, this is always less than 0. Always less than or equal to 0. Right? Because it is the negative of a complete square. So the maximum value of this portion, minus 2 x minus 1/4 squared, the maximum value is 0. Right? So altogether, the maximum value of y, alright, will therefore be minus 1 over 15. Alright? And that happens when x is 1/4, when x is 1 over 4, when this complete square is 0. Alright? And for that vertex, the vertex, now there is a maximum value, so the parabola should be something like that, right? So that it exhibits a maximum value. And position of the vertex is when x is 1 over 4, alright, and the y position will be minus 15 over 8. That is the vertex, alright. So look at this example again to see how we do the computing square. The green numbers, the magic number. Take the x term coefficient, alright, divide by 2 and take the square. That is the magic number. You add and subtract the magic number at the same time. You add and subtract the magic number at the same time, alright. You take this part together as a complete square, and you leave the constant number at the end, alright, so that you have the complete square format, and then you can get the maximum minimum by looking at the square, and also you can find the position of the vertex. Alright, you can find the position of the vertex. Now in summary, the process of computing square goes like that. If you have a general quadratic like y is ax squared and bx and c, alright, we can first take out the common factor a, that is x squared, and b over ax, alright, and c. Now, the magic number in this case will be b over a divided by 2, that is b over 2a. Take the square, will be b squared over 4a squared. Alright, we add and subtract the same number. But the first part goes to the complete square, so that is a times x and b over 2a complete square. Alright, and multiply a to the constant, we have the residue will be c minus b squared over 4a. Alright, that is the residue. So now from here we can read out the if a is greater than 0, if a is positive, then we have the minimum value of y will be c minus b squared over 4a. Alright, if a is negative, then we have the maximum value of y is c minus b squared over 4a. And that happens when the complete square is 0, when x is minus b over 2a. Right? And then from here we can gather that the vertex will be at the position of minus b over 2a and c minus b squared over 4a. Right? In other words, if you change this into a times x minus h squared plus k, the vertex is at h and k. The vertex is at h and k. Alright. This is a very important result by reading the results of the computing square. Okay, so this is it. This is how we do the algebraic skills of computing square. Thank you.